10th chapter, Random Variables. This chapter belongs to Mathematics 2A, Part 1. Last chapter completed 9th chapter, Probability. This chapter is very important. This random variable chapter problems you can solve by using probability definition and probability some random experiments. That's why probability you can learn perfectly, you get easily understood in this random variables. In this random variables, what is the definition of the random variable? In this random variable definition, suppose S is the sample space. Capital S is the sample space of a random experiment. You can do that any experiment that is random experiment. That random experiment sample space you have to take capital S. After that, then any function capital X from S to R. Here S is the sample space. Here any function capital X from S to R is called a random variable. Here is called a random variable. This is the random variable definition. Here S is the sample space, capital R is the real number. Okay students, that's why this is a random variable definition. Here suppose S be the sample space of the any one random experiment. In this random experiment, the function X from S to R is called random variable. Next one is second one. Let S be a sample space. Once again, capital S be a sample space in a random experiment. In this random experiment, X from S to R, X mapping from S to R is a random variable. That is, you know that by the definition of random variable. Then the function F from capital R to R, the function F is the any one function, the function F from real number to real number is defined by that function F of X is defined by capital F of X is equal to probability of capital X less than or equal to X. Probability of capital X less than or equal to X nothing but that X value equal to small x or less than small x. Here is called probability distribution of the random variable. This function F of X is called probability distribution function. This is a random variable definition. This is a probability distribution random variable definition. This is also be very important definition. Understood or not? After that, next one is let S be a sample space. Once again, here S be a sample space in random experiment. A random variable. Here what is the meaning of random variable, students? What is the definition of random variable? F X from S to R. X from S to R is a random variable. That's why X from S to R is said to be discrete or discontinuous. This random variable, here X from S to R is what, students? X from S to R is a random variable. That random variable is called discrete or discontinuous function if the range of X is countable. What is the meaning of countable? The range of X is countable. Countable nothing but that is uninfinite, not infinite, just a finite set. That set is what? Finite set, that is countable. Here a capital X is countable, that random variable is called discrete or discontinuous function. Understood or not? After that, next definition is here F X from S to R or X mapping from S to R is a discrete. What is the meaning of discrete? Discrete nothing but the range of X is a finite set. The range of X is a finite set or the range of X is countable, that is called discrete or discontinuous. Random variable with range is x1 comma x2 comma x3 comma and so on xn. Suppose you have to take xn, that is also be countable, not equal to infinity. Then summation of r equal to 1 to infinity. Summation of r equal to 1 to infinity. Here summation of r equal to 1 to infinity, p of x is equal to xr. Here what is the meaning of this one is, here in this random experiment n events are is there, or number of events is there. Sum of the all events, first events probability, second event probability, third event probability and so on, p of x is equal to last event. The sum of the all events probability must and should equal to 1. This is a very important key point of the in this random variable solve the problems. Total summation nothing but sum of the all probability functions, Here probability is n probability is there or infinity probability is there. Sum of the infinity probability is equal to compulsory 1. That is the condition of the any one random variable discrete, that the range of x is countable or finite set. In this case summation of the total probability is equal to 1. This is a very important point. We can solve the random variable 7 marks problems. These are the definition. This is the random variable definition. This one is the probability function definition, probability random variable definition. This one is the continuous, discontinuous or discrete. This is the condition, sum of the all probability functions equal to 1. Next point is what is the mean, variance, standard deviation. First you goes to mean definition. What is the discrete or discontinuous random variable? If x from s to r is a random variable, the range of x is countable or finite set. Countable nothing but the range is x1 comma x2 comma x3 and so on xn, then that is called discrete or discontinuous. In this case mean is equal to summation of I is equal to 1 to n xi into probability of x is equal to xi. This is a formula of mean. Here the function, probability function is discrete random variable. What is the mean formula? Mean formula summation of I is equal to 1 to n. Summation of I is equal to 1 to n. Suppose here n finite sets are given, then summation of I is equal to 1 to n xi. Nothing but you can write first I value 1, 2. Here what is the value meaning of I value 1 comma 2 comma 3 comma and so on n. You can write all. Summation nothing but sum of the term. What is the meaning of summation? Summation nothing but sum of the terms. This is a mean formula. Here mean are denoted with x bar. This is very important point. Mean are denoted with x bar. X bar equal, what is that formula? Summation of I is equal to 1 to n xi into p of x is equal to xi. Mean is completed. This is a very important formula. After that variance. After that what is that next one? Variance. What is the meaning of variance? Variance nothing but here variance is equal to summation of I is equal to 1 to n xi square into p of x is equal to xi minus mu square. Here this is a variance formula. What is that formula? C to n's. Summation of I is equal to 1 to n xi square p of x is equal to p of nothing but probability of x is equal to xi minus mu square. Here mu is the mean. Here we can write x bar also be mean also be noted with mu and mean. X bar both are similar. Sometimes you can write mu, that is the mean. Here mu nothing but mean. Here x bar also be called mean. That time here x bar mean are denoted with x bar or mu. You can write any one, that is the symbol of the mean. This is a variance formula. Variance formula what students? Summation of I is equal to 1 to n xi square into p of x is x equal to xi minus mean whole square. You can write mean whole square is correct. After that variance are denoted with sigma square. Variance are denoted with sigma square. Then sigma square equals summation of I equal to 1 to n xi square into p of x is equal to xi minus mu square. Mu nothing but what here? Mean. This is a variance definition. Next standard deviation. Standard deviation SD is equal to square root of variance. What is the meaning of standard deviation? Standard deviation nothing but square root of variance. That is called standard deviation. This standard deviation are denoted with sigma. Standard deviation are denoted with sigma. Sigma is equal to square root of variance. What is the formula of variance? Variance formula square root of summation of I is equal to 1 to n xi square p of x is equal to xi minus mu square. This is a variance. Square root of variance is called standard deviation. These mean standard deviation, variance already explained measures of dispersion chapter. That is a separate way. This is this total mean variance standard deviation in random variable totally depend on probability. Depend on which chapter? Probability. That's why this is a very important formulas. Mean, next one is variance, after that standard deviation. These three formulas you can read and write perfectly. You get easily understood 7 marks problem in exercise 10A.